Your boss comes to you and says, I'm hearing that we can make our company policies searchable using something called RAG. Can you show me an example? You're not totally sure, but being an AI experimenter, you say, give me an hour and I'll put something together. In this video, we'll explore your process of figuring out Retrieval Augmented Generation, or RAG, how it is usually built on top of a vector database, and finally, we'll make your boss's new SOP document totally searchable. Back to your story. After panicking for 45 seconds, you stabilize and you start researching. You find that the most common type of RAG uses something called a vector database. This is not the villain in Despicable Me. Instead, you learn that vector is talking about the mathematical concept vector, which simply means an ordered list of numbers. Your boss has been talking to you about SOPs, so you know this is the one that he wants in the system. He's written the standard operating procedure for his dairy farm, and he's got a ton of stuff. We're talking about infrastructure, biosecurity, we have facility, feeding, nutrition, health management, and it's 5 pages of data. And there's a lot of good stuff in here. So you know what he's going to want is you to take this information and then make it searchable. And we're going to do that with a vector database. Let's quickly examine the crazy way vector databases split up your document and store it into multi-dimensional space. Right after that, we'll see how to store your boss's SOP in a real vector database using make.com. So if you look at this point on the screen here, you're going to see that you have a 2 and a 4. And you remember from 4th grade math or 5th grade math that this 2 represents the x coordinate and the 4 represents the y coordinate. And so that is a single point in space, but it's made up by 2 numbers. If you added a third number, you would turn into 3D, just like in a video game. Now, the key here is we're always wanting to see how close are 2 points in space. And so if we wanted to add another coordinate, this other coordinate, is it far away or is it close? Well, if you look, draw a straight line, it's pretty far away, but you'll also see that it's kind of close in the x dimension, but it's really, really far away in the y dimension. And so that y dimension makes the whole thing pretty far. What if you did this in 3D space? What if you did it in 4D space? Once we get to 4D, we can still represent that with time. But then once we get to 5D, we really don't have a way to conceptualize what's going on there. But we know that we can go to infinite dimensions. And this is the key of vector databases. So when you break apart your document, and that's what we're going to do here, you break it into chunks. And each of these chunks we represent with a series of numbers. And they're exactly like what I have on the screen, except they go on instead of 2, 3, 4. Now we're going to like 1,500 dimensions. That allows us to get a very rich representation of lots of different English language texts. And then we can compare the distances. Mathematically, it works, even though we can't conceptualize it. We compare those distances across those 1,500 plus dimensions, and we'll see which are the closest. So I put my SOP documents in, and they're all converted into these long strings of numbers, which are called vectors, hence the term vector database. And then I put a query in. So my SOP about dairy farm management, and I say, tell me about the barn protocols. The word barn is going to have specific numbers that are close or far from a lot of these other pieces of text. And so that query that I put in is going to be mathematically closer to some of these points in the vector database. So all the vector database does is says, oh, here's the top, say, 3 points or the top 5 points in closeness. Again, closeness in 1,500 plus dimensions. And then it grabs those 3 points and it shoots them back. Now we'll walk through at a high level what this make.com automation does. So you can see it, get the concept of it, and then we'll dig into each piece so that you can see how to build it yourself. We're going to have this folder inside of Google Drive, and it's called Searchable Docs. And we put this Google Doc inside of here. Whenever we add new SOPs, they're automatically going to get put into our vector database. Here's our automation flow. In a Google Drive, we're going to watch for new files to show up. Then we're going to pull that file. So right now we're just watching Google Docs files. We're assuming that all the SOPs are in that. You could do it with PDFs or something like that. I have a video if you'd like to watch on how to pull text out of a PDF, and you could put that right into here. We then do a text parse, and this is just getting the data cleaned up for putting into the OpenAI flow. And what that means is we're saying, hey, new lines don't work very well with what we're going to do with the AI here. So we're going to take out the new lines, and we'll show the details here in a minute. Then we hit OpenAI and we say, please take this large Google Doc, and I want you to break it into evenly sized chunks. And those chunks are going to then later be turned into those strings of numbers, vectors that we talked about. Once we have those chunks, we then push it into this other OpenAPI module. What this module does is it goes and says, hey, OpenAI, I've got a chunk of text. Could you exchange this chunk of text for a string of numbers? So it's taking this and it's using a specific algorithm that OpenAI has, and it's going to give you back a string of numbers. Those vectors, then, you're going to put them through an iterator so that you can make sure it does all of them one at a time, because you need to take some steps in Pinecone. We'll go through the steps here in a minute. And Pinecone is a vector database. I'll show you how to sign up for that if you don't have an account already. And Pinecone, one by one, will take each of those vectors along with the original text and store it for you. Once it's stored, then you'll be able to come back in and retrieve it by putting a query into the system. Hey, if this content has been helpful so far, would you take a moment and hit the like button below? That'll help me reach more people. If you'd like to see more content like this, would you also take one more moment and hit subscribe? I'm going to keep releasing trainings like this to help you become the AI expert in your company. Digging in just a little bit more, you've got a Google Drive connection that is listening to that specific folder, Searchable Docs, and we're just going to take in one at a time on this one so we're not processing too many at once. We then listen for the Google Docs. So if it kicks off, if it finds something, the Google Doc is going to grab the file ID and it's going to grab the content of that document. Then it goes into text parser. It uses this thing called a regex pattern, and that says, hey, if there's any new lines in this document, you need to take them out, and we're just going to replace them with a space. And I'll put this in the description of the video so you can pull that out yourself if you need to. And then we're going to say, hey, the text content that came from Google Docs is what you want. That's then going to go into this first OpenAI process. That takes in the text to parse from here. And then we give it a prompt and we just say, hey, split this into a chunk of approximately 500 words. Make sure no sentence is cut off midway. We could write code that would do this, but OpenAI does it so effectively that it's kind of easier to just tell it to do it. And then we take that out into structured data. So this is transform text to structured data. And we say, hey, I want it to be called chunks. And then we give it a little bit more description about that again, because the more description you give, the more accurate results you're going to get. And this is important. We say we want it in an array of type text. And that is what allows us to then move it through the rest of the process. Then we go to this one called make an API call. This one has to call the URL v1 embeddings. There's no module to do this directly in make.com, so you have to use the make an API call one. So I'm going to paste also this information down here so you can copy and paste this out of the description. And then you're going to do a v1 embeddings post, content type, application JSON. And then in here, you're going to put in this body of all of the chunks. So you're going to grab what you're doing here, and I'm not going to go into exactly what this is doing. You can look at that yourself. But you're taking all the chunks of text and you're wrapping them up into a format that the OpenAI API can understand. And you're saying, hey, I want you to use this thing called text embedding ADA 002. So this is one of the models, and we're going to use this exact same embedding format in the vector database in a little bit. And then encoding format is float. That's a kind of number in computer science. Then the last two pieces, we go into an iterator. And this is a make.com thing. So hit map here, put this in here, and we're going to say all the stuff that came out of this, we're going to iterate through each of the items. And for each of the items, we're going to take an action. And that action is to put this upsort of vector, put it into Pinecone. So Pinecone is the vector database. So Pinecone doesn't help you with all this stuff. It would be great if they did. I hope that they build some functionality to make that easier in the future. But you have to prepare all this text to get it ready to put into the vector database. And that's what all this work ahead is doing. So first, you got to give it an ID. It's got to be unique. And so we say, well, the easiest is it's got a document ID from Google Docs. That's unique. And then we'll add an index, so a dash index of which of the chunks it is. Then we're going to take those embeddings that we just calculated. So these are coming from the iterator. And then we come down here and we say, we also need some metadata. We want to be able to remember which document it came from. And then most importantly, we want to be able to know what the original text was. Because when we do our query into the system, when we build our chatbot later, Pinecone is just going to say, hey, these are the vectors I found that are closest. If we didn't store the original text with that vector, we have no way to get that vector back into the original text. So we've got to store the original text with the vector inside the database. Pinecone doesn't really care about what text you put there. All it really cares about is the location of that vector. If we were going to go a step further for a full production kind of system, you'd make another scenario that would watch for deletions of files. You would say, hey, if any files get deleted out of this folder in the other scenario, then go grab that file ID and then go into Pinecone and do a query for all of the vectors that have that metadata of file ID that matches and delete them. That way, or your Pinecone won't fill up with data that you don't need. It would be exactly matched up with what's inside your Google Docs at that point. So we start this now. We've added our Google Doc, the newest one. And then we come in here, and for the demonstration purposes, I'm going to click run once. In production, you would turn this on, and then it would scrape every 15 minutes or 5 minutes, something like that. So then I'll hit run. And what it's doing is going into Google Drive, and it's grabbing everything that's in there, and it's saying, hey, look, I found a file. Here's the thumbnail to it. Here's the file ID. And then in Google Docs, we're going, all right, we have the file ID, the document ID. And so now we go in and we say, hey, what do we have? Oh, look, here's the text content. And you see all this text, great text, but there's lots of line breaks. So then this guy says, hey, getting all this text for coming in, let's go ahead and take the line breaks out. Okay, so you see there's no line breaks in the text that came out of here. Then we go into OpenAI. This can take a while because it's actually a 6-page doc. So it went through and it created some chunks. This is an array, so there's 1, 2, 3, and we have 11 chunks. Then it goes in here and it says, hey, turn these chunks into something I can use. So we'll look at this. Look, there's 11 chunks, but now when you open this, look at this, the embedding, now it's all numbers, okay? These numbers are all, look how many there are. Every single one of the chunks got turned into an array of numbers, and there are 1,536. Those are the embeddings. And so we have all of these pieces of information that are associated with a 1,536 dimension point in the vector database. So we can get really accurate information about how close each of these points is to each other. This is the genius of vector databases. Then this is a make.com thing. So we come out of here and we have to use this iterator module. And the iterator, basically, all it does is it takes a input that has a bundle, a single bundle with an array, and then it gives us an output that has multiple bundles. When you have multiple bundles, all we're doing here is just taking the embedding, all that stuff back out. That allows us to go into Pinecone. You can see here, Pinecone made 11 operations. So for each bundle, we passed in the vector ID. We also gave it the metadata, the document ID, and then the original text. So all these 3 pieces of information are getting saved into the vector database. The ID of the vector itself, and then the location where it is, so all those 1,536 entries in a vector, and then these 2 pieces of information, the document ID and original text. And we do that 11 times. All those go into Pinecone. Now they're all ready to be searched. This is what Pinecone looks like. You can come here and go sign up, and that will give you the ability to get a new Pinecone database. It's free to get started. I'm not making any money off this. This is just a really popular and easy one to use. So it's logged me into my database, and you're going to then want to go create index, and you can give it whatever index name that you want. And then this is the important part, the configuration. The one that I used earlier in that API call to the embeddings endpoint in OpenAI, I used text embedding ADA 002. And so if you click that, it'll automatically set the dimensions for you and the metric. We're not going to go into all the details of this. This is just the distance calculation, what method we're using to see how far the points are from each other. If you want to be free, which I prefer free, you're going to have to just go with what they give you here. Serverless, AWS, pick the region they suggest. Put your index name in there and then create your index and you'll be good to get started. So I called mine Dairy Docs. When you go to make your connection here in make.com, they're going to ask you for an API key. So you'll go into API keys, get the API key, and then you also have to grab the name of your database right here. And that'll give you a connection into it. And then we can see here that we have all of these different vectors stored in the database right here. And it's got a document ID and original text alongside of it. And then it has the vector hidden behind that. Your boss walks back in and he asks, how's it going? And you say, watch, I can convert any of our documents into vector embeddings and I can store them in a vector database. And he stares at you for a few seconds. And then he asks, how do you get them out again? Well, that's our next video. Stay tuned. In our next video, I'm going to show you how to turn this all into a chatbot where you can say something like, how do I make sure the cows don't get infected after milking? When you ask that as a question, and then the chatbot is going to run in the background and give you an answer straight from your documents.